Type of queues. There are mainly 4 types of queues. These are simple queue or linear queue, circular queue, priority queue, and Deque, double-ended queue. In linear queue, an insertion takes place from one end while the deletion occurs from another end. So the end at which the insertion takes place is known as rear end, and the end at which the deletion takes place is known as front end. So it is strictly follows the FIFO rule. The main concept of queue is FIFO, first in, first out, which is coming first, that only process first. Is it? In linear queue, that is the main concept. So we all know that there are two ends, the front end and rear end in a queue. Front end and a rear end. First of all, if the queue is empty, both front and rear is pointing to one side. Okay, rear and front equal to -1 when the queue is empty. Okay, when we want to add it, we are inserting at the rear side. Now the front and rear is pointing to -1. So we want to insert one element like A, B, C, like that we are inserting. After inserting A, the front and rear is pointing to this position, and we want to insert more. We are pointing rear to this side and we are inserting. Again we are pointing to the next free space and we are inserting like that. Okay, so now the rear is pointing to this position and front is pointing to this position. So if we want to delete one element from a simple queue, we can only delete from our front side. We can only delete A first, then only we can delete B. So that is the concept of linear queue. Clear? In array concept, the index is starting from 0 to n-1. If the queue is full, our rear is pointing to the n-1. Actually, this queue is hold 10 elements. If the queue is full, our front is pointing to this position and the rear is pointing to this position. So our front is pointing to the 0th index and rear is pointing to the n-1 index. So at that time, the queue is full and we can't insert more because we are only inserting at the rear side. Rear side is pointing to the very last position of our queue. Okay, but we can delete from this queue. So if we want to delete A, B and C, first we can delete A. Now the front is pointing to this position. Now we can delete B. Now the front is pointing to this position. Now the front is here. This position and this position is free at that time. In the case of insertion, we are only concentrating on the rear side. So rear is equal to n-1. That is 9. In this case, we are saying it is an overflow condition even though there is a free space in front side. Okay. So that is the major drawback of linear queue. The major drawback of using a linear queue is that insertion is done only from the rear end. Let's assume that if the first 3 elements are deleted from the queue, we cannot insert more elements even though the space is available in a linear queue at the front side. In this case, the linear queue shows the overflow condition as the rear is pointing to the last element of the queue. Front is pointing to here, but there are 2 free spaces in this particular situation and rear is pointing to n-1. Only because of that, the condition is a overflow condition. That is the major drawback of simple or linear queue. Now, our second type of queue is circular queue. In circular queue, all the nodes are represented as circular. There is a circular connection. It is like the linear queue except that it is same as the linear queue except that the last element of the queue is connected to the first element. The last element is connected to the first element. It is also known as ring buffer. Another name of circular queue is a ring buffer, as all the ends are connected to another end. Let's assume that this is our front side and this is our rear side. Okay. So there is always a connection between front and rear side. Okay. So that is the concept of a circular queue. In a linear queue, if our queue is full, like this situation, R is pointing to the n-1, the last position, we are saying it is an overflow condition. But in a circular queue, if this last position is also connected to the first position, if in a case, if these three elements are free, F is pointing to this position. Okay, not this position. We are only inserting at the rear side, but if rear reaches the n-1 condition or the last element of this queue, if the front side is free, then we can insert elements at the front side also. Okay, now the rear is pointing to here and we can insert more element at this position. Now rear is here and we can do like this also. Okay, so that is the concept of circular queue. Okay, so if there is a space in the front side, we can insert at that side also. So in a overflow condition, both the conditions are there in linear queue. One is if front equal to 0 and rear equal to n-1, that is the case of one overflow condition, that is the queue is full. Another condition is if front equal to rear plus 1, then also the queue is full. Okay, so that is the concept of circular queue. Now priority queue. In priority queue, it is a special type of queue in which the elements are arranged based on priority. It is the special type of queue data structure in which every element has a priority associated with. Suppose some elements occurs with the same priority, they will be arranged according to the FIFO principle. There is some priority for each element. Insertion takes place by using the normal insertion, but the deletion occurs only based on our priority. That is the concept of priority queue. Insertion in priority queue takes place based on the arrival, while deletion in the priority queue occurs based on the priority. Priority depends on the value of that queue elements. So let's assume that this is an integer queue, contains the integer value. Mainly priority queues are depending on the value of each element. So there are two types of priority queues are there: ascending priority queue and descending priority queue. Clear? So dears, let's assume that our queue is like this. We are inserting based on the arrival. First 100 has arrived, next 89, next 34, next 59, now 74, 86, 34, 72, 101, 23. Like this, let's assume that this is our queue condition now. Queue is full with 10 elements. Okay, so in an ascending priority queue, first we are explaining ascending priority queue. In ascending priority queue, the priority is based on the value. The elements with lowest value has the highest priority. Okay, so deletion is only occurs according to our priority. So in ascending priority queue, lowest value is 23. Okay, 23 has the higher priority. So in the case of deletion, we can only delete 23 first. Now we are searching for the lowest elements in this. So here 2 34s are there. 2 34s are there. So 2 elements have the same priority. So at that time, we are doing deletion according to the FIFO principle. Which one is arrived first? So here this 34 has arrived first. So we are deleting this 34 first. We are deleted this one and deleted this also. Now we are deleting this 34. Like that, the ascending priority queue is working. Now the next value with the higher priority is 59, then 72, then 74, 86, 89, 100 and 101. Okay, so that is the ascending priority queue. Now, dears, we are discussing descending priority queue. In descending priority queue means the very highest element has the high priority. So in this case 101 has the higher priority. So we can only delete 101 first. Then we can delete 100 first. Then 89, like that it is going on. And in the case of 34, two 34s are there. So we can delete this 34 first because this 34 has arrived first. Okay, that is the descending priority. So two type of priority queues are there: ascending priority queue and descending priority queue. Mainly it is used to implement the CPU scheduling algorithms. Now it is DQ or double-ended queue. In DQ or double-ended queue, insertion and deletion can done from both ends of the queue. In normal queue, we can delete from the front side and we can insert from the rear side, but in the DQ, we can perform insertion and deletion from both ends of the queue, either from the front or rear. That is the concept of DQ. Actually, if this concept is we are implementing, the main concept of queue will vanish. It means that we can insert and delete elements from both front and rear end of the queue. So mainly it is used for palindrome check like that. Okay, because in palindrome we are considering the first element, last element, we are checking that like that. So we can use DQ for palindrome concept. I have already said that the insertion and deletion can occur at both ends. So we can say that DQ can be used both as stack and queue, as it allows the insertion and deletion operations on both ends. DQ can be considered as stack because stack follows the LIFO, last in first out. Here in DQ we can insert at the rear side also and we can delete at the rear side also. That is actually the concept of stack. So we can use DQ as stack also, and we can perform the insertion also in from both ends. It is possible to perform both insertion and deletion from one end, and DQ does not follow the FIFO principle. Because of this concept, we can say that the DQs does not follow the FIFO principle, even though we are saying it is a double-ended queue. So the concept of DQ is, so this is our, let's assume that this is our rear side and this is our front side. So we can insert from the rear side also and we can delete from the rear side also. We can insert from the front side also, we can delete from the front side also. Okay. First, in the case of first, the rear and front is pointing at the very first position. So if A is the front and rear is pointing to this position. Now if B is the front is here and rear is here. Okay, so we want to insert one more element, C. So now rear is here and front is here, like that. Let's assume that this is our condition. Rear is pointing to this position and R is pointing to this position. So we can delete from this side also and this side also. Let's assume that we want to delete A. So we have deleted A, and so our F is pointing to here. We want to delete F, we can delete F also because we can delete from rear side also. So let's assume that we have deleted F also. Now our R and S is pointing to here, the F is here and R is here. Okay, so in the case of DQ we can insert from front side also and we can insert from rear side also. So where is our rear and where is our front is pointing? From that position we can perform deletion and insertion also. That is the concept of DQ. There are two main concepts of DQ: input restricted DQ and the output restricted DQ. In input restricted queue, as the name implies, insertion operation can be performed at only one end. The insertion is performed only at one end, but deletion can perform at both ends. That is the concept of input restricted. That is, we are restricting the inputting of the value. In output restricted DQ, like the name says, output is restricting. We can perform insertion at both sides, but we can delete only from one side. Maybe it is from front or maybe it is from rear side. So that is the concept of output restricted DQ. In input restricted DQ, we are restricting input. In output restricted DQ, we are restricting output. We can only insert from one side in input restricted queue. Here we can only delete from one side in output restricted DQ. So that is the concept of DQ. So we have explained, we have discussed 4 types of queues: symbol queue or linear queue, circular queue, priority queue, and the Deque. So that is all about the types of queues. Hope it is understood. Thank you.